Across the page on page 77, we're going to look at examples 9 and 10. It says reflect the figure with the given vertices across the given line. So on number 9, we have quadrilateral STUV. We know it's a quadrilateral because it has 4 corners and therefore 4 sides. And we're reflecting it across the x-axis. So what I prefer to do is I prefer to have a rule rather than drawing it all out. So the rule for reflecting something across the x-axis is that x comma y, okay, think about what the x-axis is. It's right here. So if I had something sitting right here in the top, it would just flip down to the bottom. That changes the y value. It changes the sign on the other letter that's not in the name. So x-axis is in the name, so we're going to change the sign on the y. So that's all we're going to do on all of these. So we could actually go ahead and write S prime is at 3, -4. T is at 3, -1. Sorry, T prime. U prime is at -2, -1. And V prime is at -2, -4. Ran out of room there a little bit. But you can see all we did was to just change the sign on the y value only. So where we have -y, we made this 4 to -4. We changed this 1 into -1. We changed this 1 into -1. And we changed this 4 into -4. If any of these originals had been negative, we still would have changed the sign, so negatives would have turned into positives. And now we can graph that just to see, again, what our reflection looks like. So S is at 3, 4. T is at 3, 1. U is at -2, 1. V is at -2, 4. So you can see this is a rectangle. And if we are flipping this across the x-axis, then S prime is at 3, -4. So see, we're still on the same x value, but instead of going up 4, we're going to go down 4. Notice how S and S prime are the exact same distance from our line of reflection. Our line of reflection is right here. So if S goes up 4, S prime goes down 4. And that means that this point, which is at +3, 0, that's going to be our midpoint between S and S prime. From T to T prime, it's going to be at 3, -1. So here's 3, here's -1. T prime is the same distance from the x-axis that T is, because the x-axis should be a perpendicular bisector between T and T prime. U is at -2, -1, which is right here. U prime is its new name. Again, same distance from the x-axis. And V is at -2, -4. We're going to label that V prime, connect our dots again. And you can see how this figure was flipped from the top down to the bottom. It looks to be the same size. It's the same shape. It's just been flipped over that x-axis. Number 10. Number 10, we're using the line y equals -x. So the rule on this one, your x comma y turns into, right, yx. If this is our line, we're going to say y comma x. And then this little negative reminds us to put negatives in front of both. So we're going to change the sign and switch the order. That's like the most you could ever do to these things. Change the sign and change the order. So from A to A prime, if we change the order, we're going to have -2, -4. If we change the signs, these are both now positive. For B, this is -1, -1. So we switch the order. Still looks the same though. And then we change the signs. The negatives both become positives. Lastly, C prime, we change the order. So -4 comes to the front, -1 goes to the back, and we change the sign. So negatives become positive and positives would become negative if we had any. So let's look and see what that looks like. If A is at -4, -2, B is at -1, -1, and C is at -1, -4, our original triangle looks like this. A prime is at 2, 4. B prime is at 1, 1. C prime is at 4, 1. Okay, and you can see our line of reflection, which should be y equals -x. It's going to go through 0, 0, and it has a -1 slope. So it's just going to connect on all the diagonals down here. So once again, to kind of wrap up with how to make a reflection, our line of reflection should be a perpendicular bisector between the points that are corresponding. So B would be corresponding with B prime. On this example, my line of reflection had a negative slope. So my line that connects B and B prime would need a positive slope, and we can see that it has that. The way we can make sure that it's the same distance from B to B prime, the way we can make sure that this line goes through the middle of the line connecting B and B prime is we can check the slopes. I did one repetition of the slope on this bottom left side of the line, and I did one on the top right. So we have verified that this green line is a perpendicular bisector. That would be true if we connected A and A prime and C prime as well. So for C and C prime, for example, up 1 and over 1, it's a second one, and that's another half. So there's our midpoint. So up 1 and over 1, I'm sorry, I did that 1, 2, and a half. So there's the rest of the half, and then 1, and then 2. This is too high. It's going to go right there. So it's perpendicular. It's a bisector because we did the same number of slope counts on either side. And that is how we make a reflection across a specified line. The other thing that we might do is we might figure out what the line of reflection is. The bottom of 77, you already had these two triangles drawn, or they did, and they wanted to tell us where, they wanted us to tell where the line of reflection went. So we just kind of do the opposite steps that we've been doing. Instead of having this line, we're trying to figure out where this line went. So you would start by connecting corresponding points like A and A prime. I probably would have started with B and B prime because they're closer together and a little bit less work. So we're going to start with some points like B and B prime. And we're going to make a line that connects them. And we're going to see what the slope is of that line. So from B to B prime total, I would go down to the slope of BB prime. I went down 2, and then I went over 1, 2, 3, 4. So when I simplify that, I can see that my slope is -1/2. And so knowing what the slope is of this line, we can then make a perpendicular slope. So the slope that's perpendicular would have to be positive 2 over 1. We flip the fraction, we change the sign. So we know that our line of reflection needs a slope of 2. We can also figure out where the midpoint is of this line from B to B prime. The midpoint is going to be exactly halfway between B and B prime. So you could do that with midpoint formula. You could average your X's and average your Y's. Or if you have a graph like this, really I can just cut these slope numbers in half. So instead of going down 2 and over 4, I can take half of this 2 and half of this 4. I can go down 1 and over 2, and that would be my midpoint of the whole line. Particularly if the halves of these two slope numbers are going to be whole numbers themselves, like half of 2 was 1, half of 4 was 2. That might be a quick and easy way to do this if you have a graph handy. So we have a slope, we have a point, we have everything that we need to make a line. We can draw the line by going up to and over 1, because that's what our perpendicular slope is. Up to and over 1, up to and over 1, up to and over 1. Then we can go down 2 and backwards 1, down 2 and backwards 1. And you can see this is exactly line L that was drawn for us. If we needed to give the equation of that line, we still absolutely could do that. We're going to use point slope form. Y minus, we're going to use this point right here because line L has to go through this midpoint of the line BB prime. So the coordinates here are 0, -1. So y minus -1 equals 2 parentheses x minus 0. That is your point slope form. We can simplify some stuff. So let's do all that. So this is going to be y plus 1 equals 2x. 2 times 0 is 0, so I'm going to leave that off. And then we can just subtract 1 from both sides. So our result would be y equals 2x minus 1. We had the points that we could draw the line, and we had enough information that we could also give the equation of that line as well. Let's look at page 78 for an example.